Welcome to our deep dive into pre-processing theory, where we'll explore how raw, messy data transforms into the clean, structured foundation that enables successful machine learning projects. Data pre-processing represents the foundation of every machine learning project, and understanding its principles thoroughly will dramatically improve your model's performance and reliability. This systematic approach to data preparation often determines the difference between successful and failed AI implementations. Data pre-processing transforms raw, messy data into clean, structured formats suitable for machine learning algorithms. The fundamental principle garbage in, garbage out means that the quality of your model depends entirely on the quality of your data. No sophisticated algorithm can overcome the limitations imposed by poorly prepared data, making this foundation phase absolutely critical to your project's success. Our systematic data preparation journey follows a logical sequence that builds quality at each step. We begin with raw data in its natural unprocessed state, then import and explore to understand what we're working with. Next comes clean and transform to address quality issues, followed by split data set to create proper training and testing partitions. This methodical progression ensures that each step builds upon solid foundations, ultimately producing data that's ready for ML algorithms. Data import and exploration represents our first encounter with the raw material of machine learning, much like a master craftsperson carefully examining wood before beginning construction. During this critical phase, we systematically gather data from various sources, CSV files, databases, APIs, or web scraping, while conducting thorough initial inspection. We examine the dataset's shape, data types, and basic statistical properties, identify missing value patterns, and explore data distributions through visualizations. This exploratory detective work reveals the challenges we'll need to address and guides our pre-processing strategy. Data cleaning transforms us into both detective and janitor, methodically investigating and resolving data quality issues that could undermine our model's performance. Real-world data arrives with missing values requiring imputation strategies, outliers that might represent errors or legitimate extreme cases, duplicate records that could bias our results, and inconsistent data types that prevent proper analysis. We employ statistical methods like IQR-based outlier detection and domain knowledge to make informed decisions about how to handle each data quality challenge. Feature engineering represents both art and science, transforming raw data into a language that algorithms can understand and learn from effectively. Think of yourself as a translator, helping the algorithm comprehend the real world's complexity. Raw timestamps don't immediately reveal patterns, so we extract meaningful components like day of week or holiday indicators. We create interaction features, apply mathematical transformations like scaling and encoding, and derive new variables that capture domain specific insights. This creative process often impacts model performance more than algorithm selection. Data splitting creates a fair examination system for our machine learning model, much like educators separate study materials from test questions to assess true understanding. We typically allocate 70 to 80% for training, where the model learns patterns, 10 to 15% for validation during hyperparameter tuning, and 10 to 20% is an untouched test set for final evaluation. Stratification ensures each subset maintains the same distribution of target variables, preventing biased performance estimates. Our pre-processing philosophy rests on four fundamental principles that separate professional practice from amateur mistakes. Never allow data leakage by using future information to predict the past. Apply consistent pre-processing transformations to both training and test data to ensure fair evaluation. Preserve your test set's integrity by touching it only once for final assessment. Document every pre-processing step meticulously to ensure reproducibility and enable others to understand and validate your approach. Consider a customer churn dataset with typical real-world messiness, missing values in age columns, categorical variables like gender and contract type, different measurement scales between age and income, and outliers in monthly charges. Our systematic pre-processing approach would impute missing ages using median values, apply one hot encoding to categorical variables, standardize numerical features to common scales, and carefully investigate outliers to determine whether they represent errors or legitimate extreme cases. Proper data pre-processing can improve model accuracy by 10 to 30%, representing one of the highest impact activities in the entire machine learning process. The commonly cited statistic that data scientists spend 80% of their time on data preparation reflects the fundamental importance of this phase. This significant investment in preparation pays substantial dividends in model performance, reliability, and deployment success. Now you got a very good overview of data pre-processing theory. In the next session, we will learn about modeling theory. So guys, see you in the next session.